Alrighty, so there was one thing I did want to talk about with respect to the law of sines. Again, guys, just as a quick review, when we're talking about the law of sines, we're basically saying if you have a known angle and its opposite side is also known, we can actually go ahead and create a ratio of the sine of the angle with the length of the opposite side. And then based on that, we can, as you can see, we have the three angles with their corresponding opposite sides, and we can set that up as a ratio. So, if you just look at two of those, as long as you know out of those two ratios, if you know three quantities, you can find the fourth unknown, right? And then we can kind of build it up from there. So basically, the idea is you should know two angles and one corresponding side, which is kind of what we had done in this example over here. So two angles, one corresponding side. Or as we had seen in this last example, where we had two known sides and one of the corresponding angles. But if you will remember, in this example, we had come up with two different values when we started setting up our proportion here, right? So we had the known angle 85, its opposite side was 12. So we set that up as one ratio. And then we had the known side 9 and its opposite angle was beta. So that's what we started out by finding. But for beta, you will see that we did in fact come up with two two values for the angles. And so obviously when we look at those two angles, then we kind of had to think about, okay, which one would make more sense? So when you put this in, the idea that a triangle will have three angles add up to 180 degrees, when we put that in, you will see that with the second angle value of the 131.6562, we're just rounding it up to 132 for now. So you will see when we put that in to find the third missing angle, it actually ended up giving us a negative value for that third missing angle, which obviously would not make sense. So that told us, okay, we need to discard that 131.6562 measurement and only stay with the 48.3438. And then, of course, our following calculations were based off of that. So you can see once we then tried to find that third unknown angle, obviously it came out to be a number which made more sense. It was a positive 46.6562. And then, of course, using the law of sines, again, we were able to find that third missing side. So when this happens, this is what we would say is a ambiguous case. And this usually arises when you have two sides and an angle that is not included between those two sides. So basically, in an ambiguous case, you will find that you can actually come up with two solutions, one solution, or no solution at all. So of course, in this example, we came up with one single solution, right? Because that second one did not make sense. The 132 would not work. So obviously we had no results coming from that angle. So we only came up with one result, and we came up with our answers following that. So let's take a look at couple other examples here where we may have some of the other ambiguous cases and how we would go about dealing with them. So you can see in this one, try it now, number one, we are given the angle alpha, which is 80 degrees. We are given side A, which is 120, and side B, which is 121. So of course, they're asking us to find the missing sides and angles, and of course, try and see if we come up with more than one solution. And if we do, we want to tackle both of those. So let's go ahead and take a look at how we can break this guy down. All right, there we go. So let me just copy over these values over here. So we are given alpha is 80 degrees, side A is 120, and side B is 121. Okay. All right. Okay, 80 degrees. Side A is 120. Oh, come on. Side B is 121. Okay, so obviously, if then that would be associated with angle beta, right? So we can say, okay, we need to find angle beta. And then the third side would be C. So we would need to find the missing side. And then remember its angle, we are calling it gamma. So we would also need to find the third missing angle, which would be gamma. So since we do know alpha and its opposite side A, we can go ahead and set that up using our law of sines function. So of course, you would then end up with sine of 80 degrees over side A, which would of course be 120. And then since we know side B, we know that's going to be 121, which means we are finding sine of sine of beta. So you'll start by setting it up in this format. And then, of course, like I said, use cross multiplication to help you isolate that sine of B. So we'll go ahead and multiply these two sides. We'll go ahead and multiply these two sides. The other way you can think about it is since we only want to get sine of beta by itself, so you can do the cross product, or you can also set it up as where you are just getting rid of the denominator on the sine of beta side. So you can also say, you know what, I can simply just multiply both sides by 121. And that will also get me where I need to be. So of course, on the right-hand side, you end up canceling that out and you're just left with sine of beta. So that would, and I'm just going to put sine of beta on my left-hand side. As some of you might know, I prefer leaving my unknowns on the left. So just going to move sine of beta to the left-hand side. And then we had sine of 80 degrees. Over 120. And then, of course, you're multiplying that with 121. So just to show you that very quickly on Desmos, let's do the scientific calculator. So we have sine of 80 degrees, and I want to make sure our calculator is in degree mode. Divide that by 120, and then multiply it by 121. So you will see this value comes out to be 0.99301. Now remember, guys, the range for the sine function is between -1 and +1. So you want to make sure because obviously to get beta, we are going to have to use the sine inverse function, right? To find out what angle beta will be. So we want to make sure that this answer that we come up with before you do the sine inverse function is going to be a value that is going to be between -1 and +1. So since this guy works out, we can now go ahead and say, okay, we are going to do, to get beta by itself, we are going to use the sine inverse function. So you will have sine inverse on that value of 0.99301. 44843. And I'm just keeping all the decimals. I do not want to prematurely round this answer. So of course, we're just going to keep all of this. So that should be a 4. All right, so let's see what happens when we use the sine. Oops, sorry. Not sure what happened here. There we go. All right, so here's our sine inverse under the function menu option. And we are doing sine inverse on this answer that we just came up with. So I'm just going to use the answer key. And you can see this guy is coming out to be 83.2237. And maybe we'll round it to 1 or 2 decimal places. So this is coming out to be approximately 83 point, I'm gonna go maybe 2 decimal places, 22. And obviously, since the original angle was in degree measurement, we know this guy is also going to be in degrees, right? Now, remember, again, we are actually going to come up with two angle measurements over here because, as you know, the sine function will be similar in, the two quadrants. So you would end up doing, what will this guy be? Let's see. So we would do, I know it's 180. Come on, buddy. Minus 83.22. So that will, of course, then come out to be, what will it be? 96.78. And I actually did that on my handheld calculator. Sorry, I guess I should have done it on Desmos. But yeah, just 180 minus 83.22, and you get 96.78. So now both of them technically can still be viable solutions because we know that three angles should add up to 180 degrees. Since my original angle was 80 degrees for alpha, obviously with these guys being 83.22 and 96.78, we still have room for the third angle to accommodate within that 180 degrees, right? So we would actually need to keep both of these solutions. So you will now need to do a calculation based on both of these angle measurements. So beta can be, and you can call it if you want beta sub 1. So you can say, one side of the value could be 83.22 degrees. And for the other one, we can say beta sub 2. And that guy was coming out to be 96.78. Okay, so based on this, we will now need to calculate our missing angle and missing sides. Of course, we can go ahead and do the angle first. So and again, I'm going to call this as gamma sub 1, which you can imagine would be 180 degrees. Ooh. 180 minus the original angle, which again, remember, was 80 degrees. So, Gabriel, yes, with my open math, sometimes Gabriel is just asking about the rounding rules here, guys. So with my open math, sometimes they'll tell you round it to the 10th or round it to 2 decimal places. And then sometimes they don't give you the rounding at all. So in that situation, Gabriel, I'd probably keep all the decimals in my solution because I don't know what the rounding rule would be. And a lot of times my open math will take 7, 8 decimal places, right? Because a lot of times they will just accept when you put the exact value instead of rounding it. So I would look for the instructions. If there are no instructions, then I would say keep the decimals. Okay, alrighty. Okay, so Phoenix is saying the bare minimum when unspecified is rounded to 4. So yeah, I would definitely keep a couple more extra digits in there if they are not giving you a rounding rule just to be safe. All right, I'm glad we did get a chance to talk about that. All right, guys, so let's go ahead and find our gamma 1. So that would be, like I said, original angle was 80 degrees for alpha. So we'll go ahead and do that. And then we had 83.22 for beta 1. Again, I don't know why this screen does not let me do curved numbers, but let's go ahead and do that. So we had 180 minus 80, which is of course 100, and then subtract 83.22 from that. And you can see the gamma 1 angle is coming out to be 16.78. And this will of course also be in degrees. Oh dear. Come on, buddy. Okay, so this is for gamma 1. Now, gamma 2 for the other angle would obviously be same thing, 180 degrees minus 80. Okay, and then minus the 96.78. Okay, so let's see, 180 minus 80 minus 96.78, and you will see this guy is coming out to be a very small angle, but technically it is still a positive value, right? So 3.22 for gamma 2 here. So as you will see, we are obviously leaning towards two solutions to this triangle. And the main thing is we do not have an image of the triangle, right? So we really don't know if one answer would be better than the other. And so in this case, we have to keep both the situations going because, like I said, there's no image, so we don't know what it might look like. So, okay, now that we have our gamma, we can go ahead and calculate the missing side, right? That's the third missing side. So in this case, I would definitely fall back on the known values, which was the sine of 80 degrees that we were given for angle alpha. And then remember, side A was given to us as 120. So I would use that. And then, of course, on the other side, we will then use sine of gamma 1, since we're finding side C. So gamma 1 was 16.78. I really apologize, guys. I don't know why this is not letting me write properly at all. 16.78, and this is of course in degrees also. And then of course over side C. So same thing, I would say cross multiplication, because we do want to get C by itself. So we would actually end up multiplying. So to get C by itself, you would have to first multiply 120 with sine of 16.78. And then we would be dividing both sides by sine of 80 degrees. So while I'm writing this out, go ahead and find out what those angle measurements, that side measurement will be. And pretty much we'll be doing the same thing on gamma 2 also. So I will still use my known sine of 80 degrees. Over our original value of side A, which was 120. And then and you know what? I will call this C sub 1 and C sub 2 just so we can kind of keep that notation going. So for C2, we will then have on the other side sine of angle 3.22. Divided by C sub 2. Okay, so as you are getting C sub 2 by itself, pretty much the similar thing here, you would be taking 120 and multiplying it with sine of 3.22 degrees. dividing that by sine of 80 degrees. All right, so what are your answers coming out to be? Okay, I've got Phoenix, you've got approximately. So I would definitely keep at least 1 or 2 decimal places in my answer, Phoenix. Because again, they didn't really specify what the rounding rules were, but yeah, we would definitely want to keep some form of decimal. Okay, got it. Thank you. So C1. Saving some typing, okay. All right, guys, so let's take a look here. So we are taking 120 multiplied by sine of, what was that first one? 1678. So 16.78. And then, what did I do? Dividing it by sine of 80. So yeah, you can see for C sub 1, we are coming up with approximately, if I had to round this to 2 decimal places, I would probably say 35.18. So that would come out to be for our C1 approximately. And they didn't really give us a unit of measurement for the length. So we don't know if this is in, inches, centimeters, or feet or whatever. So we'll just leave that as 35.18. And then for the other side, C sub 2, we were doing sine of, this was the angle measurement of 3.22. So you would be doing sine of 3.22. And then of course, dividing that by sine of 80 degrees. So you can see again, rounding this up to 2 decimal places will give us approximately, what would that be, 6.84? So as I was saying previously, we would need to keep both the solutions. We cannot discard any one of them. The situation in example 3 was different here because when you went to find that third angle, we got a negative answer, right? So we had to discard it. But in this example, we do actually have to keep both the solutions. So before we move on to angle 4, did anybody have questions on this try it now example here? Anyone who was not able to come up with the answers? Okay. Alrighty, guys, if you do not have any questions, let's get back here. So this one is talking about, again, same thing, right? Find all the possible angles. If one side has a length 4 opposite the angle 50 and a second side has a length 10. So of course, if you have a length 4 and the opposite angle is 50, we would of course set them up as the ratio themselves. So sine of 50 over side 4. And then since we know the second length, we can go ahead and find its corresponding opposite angle, and they're just calling it sine of alpha. So you will see when they isolate the sine of alpha by multiplying sine of 50 with 10 and then dividing by 4, you will see that sine value is coming out to be 1.915, which is more than the range of the sine function. So since this is outside of the range of the sine function, we are actually not going to have a triangle which will satisfy these values. And so you do not even have to do sine inverse to find angle alpha. And basically we are saying since there are no triangles that can be drawn with these provided dimensions, we are actually going to have no solution to this problem. So this is kind of what we were talking about when we were mentioning ambiguous cases, because, we did mention that you can have 2 solutions, 1 solution, or no solution. So between example 3, try it now, number 1 and example 4, you've kind of see how those 3 cases would break down, and what you would have to do depending on, do you have only 1 solution, 2 solution, or no solution. So just kind of keep that in mind. And remember, this comes from the idea that you are given 2 sides and 1 corresponding angle. So this is where those ambiguous cases come from. So 2 sides and 1 corresponding angle, and that angle is not sandwiched between the 2 known sides. So it's got to be either this angle here, or it's got to be this angle over here. That's when the law of sines kicks in. Okay, so that was example 4. Yeah. All right, let's take a look at this guy over here. So this one is saying, okay, find all the possible triangles if one side has length 6 and angle 50, and the second side has length 4. So you will see in this case, again, since length 6 and opposite side angle 50 are together, we go ahead and set them up as one ratio, and then second length is 4, and then its unknown angle. So now we go ahead, same thing, cross multiply, get sine of alpha by itself. And you will see in this case, your sine value, or the simplified answer, is coming out to be 0.511, which is of course well within that range of -1 and +1, right? So we can do the sine inverse to find the angle alpha. And you will see this is coming out to be approximately 30.710. And then of course, for the second solution, we can come up with 149.29 0. So obviously, based on both of these, we should be able to continue for now. So with the angle alpha being 30.710, when we go ahead and find the third missing angle, you will see that third missing angle is coming out to be a positive 99.290. So we can definitely find its corresponding missing side. So set it up with the sine of 50 degrees divided by 6, and then sine of 99.290 degrees divided by c. So finding that unknown side, and you can see that side is coming out to be 7.730. Now, when we go back to that second alpha angle of 149.290, you will see once we try to solve our third triangle value with that, this is where it's going to fail, because, like we saw previously, this is coming out to be a negative angle, right? So since it's coming out to be a negative angle, you're not going to be able to move forward with that one. So you basically end up discarding that solution because it's not giving us a viable answer, and you only end up with a single solution here. So this guy, of course, looks very similar to what we had done in example 3, but just again, one of those situations when you have an ambiguous case when you are working with these types of examples here. Everybody okay on that? Mark and Mav, that's a lot of conversation going on between you two, please. All right, guys, let's take a look at our try it now, number 2. So again, they're giving us angle alpha, they're giving us side A, they're giving us side B, and asking us to, of course, find the missing sides over here. So let's try that. Okay, so this was try it now, number 2. Oops. We are given angle alpha, which was 80, 110. Okay, so 80. Side A is 100. And side B is 10. Okay. So of course, with side B, we would be looking at angle beta. And then we would also be looking for side C and gamma as the third angle. Okay, so setting up our ratio, of course, we would still start out with sine of 80 degrees. Oops. Over side A, which is 100 in this example. And then side B is given to us as 10. So of course, we are then trying to find beta, right? So that would be sine of beta on the numerator. Okay. So yeah, just like we did before, you want to get sine of beta by itself. And to get sine of beta, we would basically end up doing, multiply both sides by 10, essentially. So you would end up with sine of 80 degrees over 100 multiplied by 10. And can anybody tell me if that is going to be within the range of our sine function? Is it going to be between -1 and +1? So sine of 80 degrees divided by 100 multiplied by 10. Right, so obviously we can see that's going to be well within -1 and +1, 0.0984. You know what? I'm just going to write it down here. So since it is within the range, we can go ahead and do the sine inverse function. So sine inverse on 0.09, what was it, 848? Zero 7753. Okay, so let's see, how many angles does that give us? Do we come up with a single answer or more than one? So sine inverse on the answer, and you can see this guy is coming out to be 5.65, which means we definitely have room for another value in there. And again, I'm just going to keep that 2 rounding decimal places for now. So 5.65 for this guy. So if we did another value, that would be 180 minus this angle. And again, guys, this is in degrees. So you can see when we do 180 minus 5.65, that will come out to be 174.35. So I want to take a second and think about this. 174.35. So can we keep both of these angles? The 5.65 and the 174.85? Remember, the original angle alpha is given to us as 80 degrees. So just take a minute and think about this. Can we keep both angle measurements, 5.65 and 174.35? All right, Musab, you want to tell me why? Musab said no. What would be our reason for not keeping both the angles? Remember, guys, we are talking about a triangle with 3 angle measurements in there. Very nice. Perfect. Yes, because when we take 174.35, angle alpha of 80 degrees plus whatever that third angle might be, you can obviously see that total is going to be much, much larger than 180 degrees. And we know that 3 angle measurements added together should be 180. So yeah, that's why we will need to discard this answer, because this is not going to be within the definition of a triangle, right? So you will not be able to keep this second angle, which means we will only end up with one solution where our beta is going to be 5.65. So now based on that, we can go ahead and calculate our third missing angle. So that would be 180 minus the alpha angle, which was 80 degrees. And then of course the 5.65 for beta. So of course that would be basically 100 minus 5.65. And you can see our gamma will come out to be 94.35. And of course, this is also in degrees. Okay, so now that we have our gamma, we can go ahead and find the unknown side C. So again, I'll begin with the known value. So we had sine of 80 degrees over the side A, which was 100. And this would, of course, equal sine of the angle we just found, so 94.35. And then side C. So go ahead and tell me, what do you think our measurement for side C should come out to be? Okay, I'm already seeing something come through on chat. Let me just go ahead and finish writing this. So again, we're trying to get side C by itself. So you would end up multiplying 100 with sine of 94.35. And then of course we would divide it by sine of 80 degrees. Okay, so let's see, we've got okay, Mav, are you not able to wait till the class ends? Okay. All right, guys, what is our answer coming out to be? For side C, when the angle is 94.35. All right, Phoenix, I see your answer. So let's take a look here. 100 times sine of 94.35. And then, ooh, what did I do? 94.35 divided by sine of 80. Oh, I'm saying 80, but I'm typing in 90. Sorry about that. Yeah, so again, rounding it to 2 decimal places, looks like it would come out to be 101.25, right? And again, they did not tell us what the unit measurement for the length was. So you can see in this case, it kind of looked like when we were first starting out that we may be ending up with 2 cases again. But because that angle measurement was so large that it would go beyond the total of 180 degrees, we ended up discarding that second angle value for beta. And so that only actually ended up giving us one single solution for this triangle. So again, guys, just be very, very careful when you are working with these 2 sides and 1 known angle, and you're using the law of sines. You can end up with that ambiguous case. All right, so moving forward, we're now looking at law of cosines, and you can kind of see the little illustration they have over here. So they're talking about, suppose a boat leaves port, travels 10 miles, turns 20 degrees, and travels another 8 miles, and they want to know how far from port is the boat. So you will notice that the angle measurement that they are giving us is actually, remember when we had talked about bearings very briefly in chapter 1, we had talked about how that angle is measured based on the vertical north-south line. So that's why, because, if this is the port from where the boat left, they're telling us it traveled 10 miles. So we've got our distance of 10 miles here. And then it turns 20 degrees. So it's got to be with that north-south line that you have to measure the angle 20 degrees. So this angle over here is 20 degrees. And then, of course, they're telling us it's traveling another 8 miles. And from that position, they're asking us to find, what the distance would be. So in this case, we're basically saying, unfortunately, while the law of sines will let us address many non-right triangle cases, it does not allow us to address triangles where one known angle is included between the two known sides. So since we know the two known sides, they are saying we cannot do a triangle where the angle in between those two known sides is included. So in this case, we bring in the idea of law of cosine. So again, they're just saying, okay, we have this random, arbitrary, non-right triangle. We again drop that perpendicular, from the top vertex to the base of the triangle. We're calling that height, h. And basically, again, you will see it breaks it up into two right triangles, each of these right and left parts. And the bottom base can be broken up into two pieces also. So they're basically saying if the left-hand side measurement is x, then the right-hand side we can do b minus x, right? Because we're saying that entire length is b. So if that little section on the left is x, the right-hand side section becomes b minus x. So now we're saying, okay, so now we can use the right triangle relationship over here. And they're basically saying, okay, if we are doing cosine of angle alpha, that's this angle here, cosine is adjacent. So x over hypotenuse, which is c. Or you can try to get x by itself by multiplying c on the other side. So we can say, okay, the measurement of x, the side x comes out to be c times cosine of angle alpha. And then, of course, using the Pythagorean theorem, of course, we can come out with what the side h is going to end up being. So they're saying, basically you can do x squared plus h squared equals c squared. Of course, the two legs added together as a square is equal to the hypotenuse square. On the right-hand side triangle, that would be h squared, b minus x quantity squared, which would equal the hypotenuse a squared. So now they're basically saying, okay, solve it for h, get h by itself, or h squared in this case. So you will see, since we have h squared equals a square, we just took this quantity and moved it to the other side. Same thing here, we took the x square, moved it to the other side. Since both of these are h squared equals something, obviously we can then set them equal to each other. So then we can say, okay, a squared minus the quantity b minus x squared is equal to c squared minus x squared. And then you can kind of see they go through that process of cleaning it up essentially, right? So you will see now we have expanded the b minus x quantity squared. So you go ahead and FOIL that. So FOIL is happening here. And then whatever you can clean up, if things cancel out, we want to cancel them out. If they don't cancel out, then, we try and combine them. Obviously, in this case, your x squared and x squared will cancel each other out. And we will be left behind with a squared minus b squared plus 2bx. You can kind of go ahead and rewrite it and get a squared by itself if you wanted to, since that would be our third side of the triangle. I don't think cosine is difficult, Phoenix. To me, sine and cosine, honestly feel about the same, but I don't know. Can't say. We are actually bringing in a substitution over here, guys, because you will see that we are taking that x value and substituting it with c times cosine of alpha, that little calculation we had done over here. So you will see that we do end up replacing this x in that final result over here. And the reason we are doing is basically we are saying, let's say you want to find side A, as long as you know side B and side C, because you will see this is in terms of B and C also. So as long as you know side B, side C, and the angle that's included in between those two sides, which will be angle alpha. And again, we can go back and look at the image of the triangle over here. So between sides B and C, let me clean this up. So you will see between sides B, this entire length is side B, and this entire length is side C. So you will see between sides B and C is your angle alpha. So that's that included angle we are talking about, right? Between the two known sides. So as long as you know the two sides and the angle that falls in between, you can actually go ahead and find the third unknown side based on that measurement. And this is kind of where the idea of law of cosines is actually coming into play. So let's take a look at that here. So you will see here in the little rectangle how if you want to find side A, you should know side B and C with the angle alpha. If you're trying to find side B, you should know A and C with the angle beta. To find side C, we should know sides A and B, and of course the included angle gamma over here. So basically they are saying, let me fix that. So basically they are saying depending on which side we dropped the altitude down from, we could basically establish this relationship using any of the angles. So, you know, depending on where you drop that altitude or that perpendicular line from, you know, we could do it from the vertex, which is at angle alpha. You could do it from the vertex, which is at angle gamma, and you could still come up with the same relationship for the other sides. But basically, they are saying the important thing to note is that the right side of the equation involves an angle and the sides adjacent to that angle. So basically, you know, the two sides with the angle included in between. So yeah, this would be your law of cosines. And you can see it looks very, very different from law of sines. So let's take a look at this one here. They are also saying, notice that if one of the angles of the triangle is 90 degrees, so they're basically saying, you know, if cosine of 90 degrees is going to be 0, so that actually means that, you know, that last term on your law of cosines where your angle, you know, you're doing cosine of alpha, beta, or gamma, if that angle happens to be 90 degrees, which is cosine of 90 is going to be 0, which means this entire term will end up becoming 0, which means it will cancel out, leaving you behind with just c squared equals a squared plus b squared, which is exactly what the Pythagorean theorem is. The two legs squared together and then added will equal the square of the hypotenuse. So they're basically saying the law of cosines is sometimes also called as the generalized Pythagorean theorem, because it's basically taking the Pythagorean theorem for right triangles and applying it to non-right triangles. So that's kind of where they're bringing that terminology in is, you know, if it was a right triangle, it would look exactly like the Pythagorean theorem. But if it's a non-right triangle, then we are basically saying, you know, we can still extend that concept to a non-right triangle, and we're calling it a generalized Pythagorean theorem. So I think it's just kind of neat of how, you know, we're able to kind of connect those two concepts together. Okay, let's take a look at an example. So coming back to our little boat over here. So basically we're saying, okay, so the boat leaves the port, travels 10 miles, turns 20 degrees, and then travels another 8 miles. So they're saying since the boat turned 20 degrees, we're saying, okay, so the obtuse angle for that non-right triangle, which is this angle we're talking about here, is going to end up becoming 180 minus that turn of 20 degrees, which will end up giving us 160. So say they're saying this angle over here is going to be 160 degrees. And, you know, of course, we're using the idea of if you have a straight angle And if one of these angles here is 20 degrees, well, then the remaining one has got to be 180 minus the 20, which gives you 160. So that's basically the concept that we're using here. So we know that obtuse angle is going to end up becoming 60 degrees. So you can see we know the two sides and we know the angle that's included in the middle. So if we call this distance here as x, well, then you can say, okay, I'm going to take 8 square plus 10 square, 2 times 8 times 10, and then cosine of the angle measurement. And again, just to show you very quickly on the law of cosines, you will see that's exactly how we set it up, right? So the unknown side on one side, and then all the known sides and the known angle on the other side. So just plug that into your calculator and you will see this is coming out to be x squared is equal to 314.3508. Since we do want to get x by itself, we go ahead and take a square root on that number. And it's coming out to be approximately, the boat has traveled 17.73 miles from the port. So this is how we would go ahead calculate the distance between the port and the boat. So law of cosines is what would help us get there. Okay, just want to give you guys a second to see if anybody had a question before we move on to our next example. All right, let's take a look at this guy here. So as again, you will see we are given the side 10, side 12, and the included angle 30 degrees. So obviously we would need to use law of cosines here again. So basically they're saying, notice that we don't have both pieces of any side angle pair. So the law of sines would not work in this triangle, which again, since they are giving you the included angle, you would know that law of sines is not going to work. So let's take a look at law of cosines here. So basically in this case, let's say we wanted to start by finding out side x, which is obviously the only unknown side. You would then set it up as x squared, and then we would take side 10, side 12, go ahead and square those together. And then it's always 2 times side 10, side 12, and then the included angle cosine of 30. Again, are they asking us for an exact answer? No, not really. So you could actually throw that entire right-hand side into a calculator if you wanted, but they're just kind of breaking it down a little bit for us. Throw that in, simplify it, get x by itself, and you will see that distance is coming out to be okay, so Musab is asking me a question here. Yeah, so obviously, Musab, if you think about it, Musab wanted to know if the negative 2 times, the side A, side B times cosine of gamma, if that could be positive or negative. I think you're saying can't be positive. I mean, it can be positive because the negative is built into the function, right? Or into the formula. So essentially, when you are doing 2 times side A, side B times cosine of angle gamma, technically that value is going to be positive, but yeah, you do end up subtracting them because that's how the formula works out to be. So I think the concern would be if this came out to be, if the right-hand side came out to be a negative answer, so negative times negative would then end up making this sign into positive. And I think that would end up creating a much larger number. But, honestly, Musab, as I'm kind of thinking, since we still end up doing the square root, even if you got a pretty large number on the right-hand side, when we end up doing the square root over here, it would still break it down into a small number. Because remember, cosine value depends on which quadrant your angle is going to fall into. So technically, yeah, you could end up with a positive or a negative for the cosine value. So I think it could work in both situations. Let's see if we do actually come across an example where we see that happening or not. So yeah, in this example, of course, you will see we are coming out with x, the third side, as approximately 6.013. Now, of course, that's coming up with this, but we still have those two other angles that we have to find out what those measurements are. So let's take a look at that. So for the missing angles, you can actually go back to using law of sines. So you will see now we are saying, okay, we know angle 30 was given to us. The side opposite to that is what we just calculated, which came out to be 6.013. And then you can use one of the other known sides to find the second missing angle. So we're going with angle theta over here, which was opposite to side 10. And in this case, we are again using law of sines. So set this up, and you can see when we simplify this, angle theta is coming out to be 56.256. And once you have that second angle, then for the third angle, which I think they're calling it as phi, you will see we can just go ahead and do the 180 minus 30, which was the given angle, minus 56.256, which is giving us the third angle as 93.744. However, you will see they are going with the other possibility for angle theta, which of course, if this guy is coming out to be 56.256, for the second value for theta, we would just do 180 minus that measurement, which is coming out to be 123.744. And they are saying if you look at the original picture, angle theta is an acute angle. So 123.44 would not make sense. And again, just to show you the image, that's angle theta over here, right? So you can see that's an acute angle. 123 makes it an obtuse angle, which would obviously be incorrect. So remember when we had done our try it now number 1, we had talked about how since we didn't have an image to go with the triangle, we wouldn't know what the appropriate answer would be. But in this example, since we do actually have the given image of the triangle, we would basically say this angle does not make sense. So you're basically going to go ahead and discard this answer. So that's why we're only keeping 56.256. And based on that, our third angle then comes out to be 93.744. So yeah, I would definitely say, in your examples, if they give you an image, then obviously use that as a guideline. If they do not give you an image, then we would have to consider both answers and keep both options going. Alrighty, so that was example number 7 over here. So they are also saying in addition to solving for the missing side of a known angle, we can also use law of cosines to find the angles of the triangle if you know all 3 sides of your triangle. So you can see in this example, none of the angle measurements are given, but we have all 3 sides given to us. So obviously we have 25, 18, and 20. So same thing, use one of those formulas. Since they're calling this angle alpha, you can base it on that. So we've got opposite to angle alpha is 20. So that's 20 squared is equal to 18 squared plus 25 squared. And of course, 2 times 18 times 25. And then you have cosine of alpha. Obviously, all the numerical numbers can be simplified and solved. So you can see we get 20 squared, which is 400. 18 squared is 949 plus the 25 squared of 225 is also being added in there. So this 949 is the sum of these two numbers here. And then 2 times 18 times 25 is coming out to be 900. So simplify what you can. And then, of course, we'll use the cosine inverse function. So once you get this fraction of 549 over 900, and then you using the cosine inverse function, you will see our angle alpha is coming out to be 52.4 410. So once you have one of these angles, basically, if this was beta and let's say if this was gamma, we can now use law of sines, right, to find the second missing angle, just like we did in this previous example. So use law of sines to find the second missing angle. And then for the third one, we would do 180 minus angle alpha minus angle beta, and that would end up giving you the third missing angle, which would be gamma. So that's how we would go about finding the angles if you were given all three sides. And that's also where law of cosines can come in handy. So questions on this example here, guys? Okay, if you do not have a question on that, let's get into try it now, number 3. So you can see we are given alpha, side B, and side C. So let's take a look at that. So this guy is number 3. Angle alpha was 25 degrees. Side B was 10. And side C was 20. Okay, so angle alpha is given to us. So just to show you in our formulas here, obviously if angle alpha is given, that means we are trying to find its opposite side, which would be side A. So this is the formula that we would be using over here. So we are trying to find A square. So let's take a look at that. So since we are trying to find A square, we have B square and C square, which are known to us. Minus 2 times B times C. And then, of course, you're multiplying that with cosine of alpha. Okay, so you will see this will come out to be 10 squared plus 20 squared minus 2 times 10 times 20. And then, of course, cosine of 25 degrees. So can you tell me what our A will come out to be once you simplify this entire thing? What are we looking at as the answers for A? And again, remember, well, let's finish finding A and then I'll talk about the rest of it. What are we coming up for our A value? All right, Jeff, I see your answer. Okay, Janice, so what did your answer come out to be once you put that in? And let's make sure we are staying in degrees. Yeah, we should be in degrees. All right, so this is going to be our A square answer, right? But this is not A because we haven't taken a square root yet. So this is coming out to be 137.47. And then whatever decimals we had after that, 68852. Okay, so yeah, then we end up taking a square root on this value to give us the side A, right? So then we would end up doing square root of the answer here, which you can see is giving us approximately 11.73. So approximately 11.73. So of course that gives you the third side, but we still have the two angles to find, right? So in this case, since we were given angle alpha, we need to find angle beta and gamma. So this is what I was going to say earlier, that, since we are going to find the missing angles, we do have to make sure we are taking into consideration any multiple options, right, that we may end up coming up with. So yeah, very good. For those of you who did share your answer on chat, you guys were right on track. Very nice. All right, so let's move on to, I guess, beta. So I will use law of sines for that. So since we already know angle alpha, which was 25 degrees, and then we just calculated side A, which came out to be 11.73. And then we can set that up to sine of beta, since that's what we're trying to find. And then side B was given to us as 10. So we'll use that. So same thing, get sine B by itself or sine of beta by itself, and then get beta by itself by using the sine inverse function. So let's do the initial calculation over here. So we would end up multiplying 10 with sine of, that should be 25 degrees divided by 11.73. So let's see what that guy comes out to be. 10 times sine of 25 divided by 11.73. Did I not do that correctly? Ten times sine of 25. Why am I getting a decimal answer there? Yeah, that looks right. I don't think that should make a difference. Even if I did that. Yeah, see? Okay. Well, actually it will work, isn't it? Because it is between -1 and 1. And then when we do sine inverse on that, so yeah, I think that should actually work out. There we go. That's what I was looking for. Yeah, so when you do sine inverse on that, we will get our angle measurement. So there we go. So then we will do beta is going to be sine inverse on that little tiny decimal answer. 0.36. And I'll go ahead and write down all the digits later. But yeah, our angle measurement is coming out to be 21.13 in degrees. So as you can see, guys, we definitely can have a second option here, right? Because then we can do 180 minus this angle measurement. And you can see that will come out to be 180 minus 21.13, and that's coming out to be 158.87. So I would still ask the same question. Does it seem reasonable to have a beta measurement of 158.87? So if you have 158.87, our original angle alpha was 25. We haven't even taken angle gamma into consideration, and you will see this guy is already coming out to be 183.87, right? So obviously we can see that 158.87 is not going to work out. Sorry, I will try writing that out later. It's just not letting me write properly. So you will only be considering that first angle measurement of 21.13. And then based on that, we would need to find our third missing angle and our third missing side, which would be the C and gamma. So we can wrap that up next time, guys. I'm so sorry. I was really hoping that we could finish chapter 3 today, but as you can see, we do have a little bit more left to talk about because we haven't gotten into the applications yet, and I would like a chance to go over those. So what I will do is, because you can only see there are only 2 more examples that we need to talk about, so I will go ahead and create a video recording just with me going over those examples, and I'll post them with our recording from today. So you guys can go and watch that as a reference, because I don't want to take another day just to go over 2 more examples. So I'll go ahead and go over those examples just so I can kind of walk you through like I normally do. So please watch that, sometime later today or maybe this week. And then let's prepare for chapter 3 exam on Monday, the 18th. So please make sure that you have all of your homework completed with a minimum of 90% grade. And then if anybody is still uncertain about their attendance, send me an email and I'll send you your updated attendance. Some of you had already emailed me on Monday and I sent you your replies back to that. If anybody else needs to know where their attendance is at, go ahead and shoot me an email and I'll get that information out to you. So please make sure you're at 90% attendance before Monday morning so you are eligible to take the exam. All right, guys. So like I said, I'll go ahead and finish those 2 examples, post that with our recording, and then I'll see you guys on Monday morning. So have a great day, guys. Everybody be safe.